Okay, for this video, let us discuss example 1.9 in your handout, and let's have find the volume of the solid obtained by rotating the region bounded by y equals x minus x squared and y equals 0 about the line x equals 2. Okay, now based on our problem, the region is bounded by this curve, that's y equals x minus x squared, and which is the parabola which opens downward. So yung graph natin, so this graph is the function y equals x minus x squared. Okay, so the graph is a parabola opening downward and whose x-intercept is at x equals 0 and x equals 1. Okay, so the graph of the parabola passes through the origin 0, 0 and this point at 1, 0. Okay, now for our convenience, since the given equation or the given function is expressed in terms of x, we will be using the vertical rectangular strip or the vertical rectangular element. Okay, now if you're going to look at the vertical element and the axis of revolution, by the way, the axis of revolution is this line x equals 2. Now if you're looking at the vertical element or the vertical strip and the axis of revolution, you can see the strip or the element is parallel to the axis of revolution. That makes this problem solvable using cylindrical shell method. Okay, now since the axis of revolution is at x equals 2, this graph or the region itself will be having a mirror on the right side of the axis of revolution. Now as you can see, kung mapapansin nyo, this given problem is almost similar to our example 1.7, which have already been discussed on the first example under cylindrical shell method. Only, yung parabola natin dito ay mas mababa at ang axis of revolution natin ay nasa sa kanan ng y-axis. Doon sa example 1.7, ang axis of revolution is at the left of the y-axis. Okay, so that is the graph of our function. And for our second illustration, now this is the solid. This is the solid form when the region is revolved about the x equals 2 line. Okay, so again, it's open to below, mas maluwag kasi mas malayo kasi to compared dun sa isa, and then flat ang kanyang bottom, flat surface to, and then again ang wall ng kanyang solid sa loob is a curve. Okay, now for the dimension of the cylindrical shell, so we need this para malaman natin kung ano yung mga values ang isa-substitute natin dun sa formula. Okay, again, as we recall, the formula for the volume of a cylinder is 2 pi. Okay, balik tayo dun sa pinaka-introduction ng ating sa pinaka-introduction ng ating topic. So the volume of a cylindrical shell is equal to 2 pi times r times h times t. So r is the radius or the shell radius, h is the height of the cylinder, and t is the thickness of the cylinder. In terms of function of x, r is the distance, or the radius r of x is the distance from the element to the axis of revolution. The height, or the h of x, is the upper function minus the lower function, or the upper curve minus the lower curve, or the upper boundary minus the lower boundary, which is given by f of x minus the g of x. And our t is the change in x, or which is equal to dx. So the formula for the volume ng solid using cylindrical shell method is given by the integral of 2 pi times r of x, which again the cylindrical or the shell radius we have multiplied by f of x minus the g of x, or the height of the cylindrical shell, and then dx is the thickness of the cylindrical shell, and that is evaluated from a to b. Okay, now from our dimension of the cylindrical shell, now again, as I mentioned from my previous video, we have to solve for the radius or the shell radius. Ang una muna natin titingnan is yung measure ng element doon sa y-axis. And again, as I mentioned from my previous video, kapag ang ating element is vertical, ang distance niya sa y-axis is always equal to x. So that's why I put x here. That's the distance of the element dun sa ating y-axis. Okay? So from our given problem, the axis of revolution is 2 units away from the y-axis. So therefore, the distance of the axis of revolution dun sa y-axis is equal to 2 units. Now, if you're going to solve for this part, that is from the element to the axis of revolution, so that is 2 units minus x, or simply r of x is equal to 2 minus x. Okay, and for the height of our cylindrical shell, so that's the upper function or the upper boundary, which is the curve or the parabola whose equation is y equals x minus x squared, and then minus the lower function, and that is y equals 0. So your f of x minus g of x is given by x minus x squared, then minus 0. Okay, and then your r of x is equal to 2 minus x. The thickness is equal to dx. That's the variable of integration, and this is evaluated from 0 to 1. Okay, so from our graph, the function or the region has the left boundary at x equals 0, or the y-axis, up to this point at x equals 1. So the lower boundary is 0, or the lower limit is 0, and the upper limit is 1. So we will evaluate this from 0 to 1. Now, if you going to multiply 2 minus x and x minus x squared, we have this integral as x cubed minus 3x squared plus 2x dx, and then evaluated from 0 to 1, it's multiplied to 2 pi. Okay, the integrating x cubed, so we have that's x to the 4th over 4, then minus the integral of 3x squared is 3x cubed over 3, or simply x cubed, and the integral of 2x is 2x squared over 2, or simply x squared. And then let's evaluate it from 0 to 4, multiplied by 2 pi. Now substituting the values, we have the substituting the limits dun sa given integral. So we have the volume equal to pi over 2 cubic units. You may verify this. You can actually verify this using a calculator and see whether the volume I computed is equal to or approximately equal to pi over 2 cubic units. Thank you.